what Picnic does. Or who is a customer, maybe? Customers, how many? Okay, some? Cool. But do you really know how Picnic works? Like actually, behind the scenes. So this thing, yeah, you know this basically. So Picnic is an online-only supermarket. So there are no physical stores. So there is no retail, and we basically get all our products from our producers, from our suppliers, based on demand. So we like very much to have zero stock inventory strategy, where we really try to reduce as much waste. And we try to be as green as possible by delivering our groceries using our cute little electric picnic vehicles that you see on the streets. And then with our routing algorithm that runs every night, we then plan the delivery of those groceries to the door of the customer. So this is basically how Picnic works. And to ensure free delivery and the lowest price, how do you actually do that? In one word, tech. So we have our supply chain very much data powered. So all the decisions we make are based on data. So do you know, for instance, what is our biggest selling product? Can you guess?
Wine?
Wine? No. This is not France.
Bitterballen.
Or Portugal. Bitterballen? No. Cheese? Okay. Bread could be, not really. Just be simple. You know, think about sandwiches, salads. What do you usually put there?
Bread.
Okay, it's actually cucumber. I don't think you would actually arrive there, but it's cucumber because we sell 1 unit, so that's why it's the biggest selling product. But if you would like to introduce a new brand of cucumber, you need to think about several things, right? So you need to look at your supply chain and take a look at your store. How will you place your cucumber in your store? How will you rank it? How will you change the search keywords to make sure that your new brand of cucumber pops up? How do you actually change the way you contact with your suppliers to make sure that those suppliers can, offer the amount of cucumbers that the people will demand? How will you change your processes in the warehouse, the way you pick them, the way you store them in the little boxes that go in the vehicles? How do you actually deliver them to the customer? How do you track if there are any issues? So to have this cross-cutting view of how actually this cucumber does, you need a data warehouse. So what is a data warehouse? It's basically the central place where you gather all the data that allows our consumers, our customers that are not you, but are the customers in our company. So the data scientists, of course, because they need basically our data to predict the future. Where are the data scientists back there? We have the analysts. Analysts, there's some there. And we have some operations. So, of course, like for instance, the people that you see there in that behind the window glass in the CS team, right? So they need to follow really how that cucumber does in terms of issues, to really pinpoint what is the point in the supply chain where something went wrong, for instance. So, something that you might not be aware of, but to model a simple order in our data warehouse, it really requires about 24 different services. And because we have indeed changed our architecture, backend architecture to microservices, this is increasing every day. So if you look at a simple, what we call an order line, so this is basically if you take a look at your supermarket receipt, you see basically an order there, you see a little article, right? So this is basically the level of detail of your data. So you can take a look at that order line from a customer perspective, from a product perspective, and from actually an accounting perspective. What is the subtotal, what is the quantity? But actually, there are so many different perspectives you can take a look at while looking at this order line. Things like, who was the shopper that actually picked that little product? What was actually the demographics of that customer? Was that customer in a poor region, in a rich region? This is influence the fact that this cucumber was purchased. Or for instance, how much time should you plan for this delivery to be delivered? Like how much time do you plan at the door of the customer? Is it influenced by the cucumber? Well, I don't think so, but it could be, of course. So this is really, really hard to combine everything together, and my talk is exactly about this. How do you combine everything together in one place without, losing data quality? So this is basically what the business wants. I wish we had more analysts here, but this is basically, so you are developers, so you can recognize with this. By the way, this meme, I did it. Some people don't like it. I think it's pretty good. So it's basically, what does the business want? The business wants to analyze everything, and when, like now. But when we tell them, okay, so now you create this endpoint, you consume this event from this queue, you do this like 24 times, and you repeat this every day, and they're like, okay, I can use Excel, right? But this doesn't really work because Excel cannot, really conform to that much amount of data. So this is what they want, right? Like pretty things. This is what they do their whole day. Do pretty dashboards to actually realize if their hypotheses were good or not. Because look around in our company. We are a pretty young company. We have little knowledge in the industry compared to the dinosaurs in the supermarket industry. So we base ourselves in data. This is a true reason why Picnic, as a startup and now a scale-up, is so data-driven. Next one. Yes. So microservices. Microservices are everywhere. All of a sudden, we were told, okay, the backend is shifting to microservice, and data engineers were like, oh my God, what will we do now? This really defeats exactly the paradigm that we, believe in, which is a monolith to centralize everything. So what does the business demand? So the business demand wants like super easy access and ready and fast, wants a consolidated, a single source of truth, wants to really do like really, really heavy analytical queries that really require the full history. And sometimes the backend cannot provide this, right? Because the backend is focused on the present, on what works now, not necessarily on the data for the past. At some point, you cannot store all the data for the past. At some point, you need to purge your data. And you have to rely in some system to historize everything, right? And the data model is really fragmented, as I said before. So only by having a consolidated data model, you can actually ensure that you can do your analysis. And most importantly, the KPIs. I know this is a very business word for you guys. You don't like to hear about KPIs. But in the end, why are we doing this, right? It's to drive those KPIs up or down, depending on the type of KPI, of course. But only by having the multiple perspectives of that order line, you can actually calculate the KPIs that are really interesting, like upsell, like these kind of things, lift, and things like this, that the business cares about. So, I know this is a pretty random, but you will understand the importance of this. So, who likes food? Who likes to go to the restaurant? Okay, see, we have something in common. So, what does food have to do with a data warehouse? Okay, let's do a little metaphor that will explain to you actually how a data warehouse works by introducing you to the data restaurant. Guess what? So, you go to a restaurant, you have a client that comes in, right? And there's a menu. And you think about, okay, what do I want? And then this client thinks about, oh, I really want a burger and fries, because we are a cheap restaurant. And it means that you need some kind of raw materials, right? You need some kind of ingredients that will come from different suppliers by different transportation methods. Maybe something like the vegetables arrive every day. Maybe the cheese is once per week because you don't use that much cheese. So you have different rates of those raw materials arriving into your kitchen. Yes, there's a kitchen. And a kitchen, like any kitchen, has a chef. Ours is very good. Javier back there. Thank you for the food. So we have the chef, right? And what does the chef use? A recipe book, right? A cookbook that will tell you how to actually assemble those raw materials together using specific instruments that only the chef can actually use. right? You don't want to have customers coming to the kitchen and dealing with those really, really sharp knives, right? Only the chef actually knows how to manipulate those knives. And of course, you want to automate as much as possible. So any good chef actually has a kitchen robot, to help with those sauces. You don't want to send the raw materials to the customer and say assemble it yourself. And then expect that people arrive to the same kind of taste, right? Because everyone will do things differently. So you have a central place in the kitchen where you do everything. And then, of course, you have someone, like the manager of the restaurant, that does some QA, right? And then delivers the product to the customer. And then sometimes the customer doesn't like it. So what he does is or she does, is put some salt and pepper if the taste is not really up to par. So let it sink in, the data restaurant, and just take a look at how is the data warehouse. Bam, exactly the same thing. So you still have raw materials, different formats, different kinds of ways of sourcing information from our operational systems, either by events or by endpoints. It doesn't matter, but there's a contract, and there's something that you expect from the backend. You also have automation tools. You use programming languages to automate those processes, and you apply techniques like dimensional modeling, which is what we use in data engineering and business intelligence in general, to normalize all this data into one conform model that has everything together in the same place. And you have some kind of an access tool to access this data, usually a dashboarding tool. In this case, we use Tableau, and for our data warehouse, we use Snowflake. And the customer has some kind of documentation, which is kind of the menu, what are the data sources that are available, right? And if the customer doesn't like the analysis, can always filter, order alphabetically, and things like this. So it's exactly the same kind of pattern. Now, high quality is good for business. The same way high food quality is good for a restaurant's business. So it's exactly the same thing. And the reason why we really try to have as good quality as possible is because we actually allow to increase our sales and reduce our costs by projects like fraud detection, fraud prevention, for instance, comparing our prices with competitors, for instance, and making sure we have actually the lowest price, recommendations, and so many other things that we do at Picnic that are only possible by having the highest quality data possible. So how do you actually measure data quality? Now this is boring, this is going to get very interesting, more into the techie stuff, but it is important to understand why do we do this, right? And if you think about your food in your restaurant, it's the same thing about your data. You want to make sure it is complete. You don't want your fries missing, right? You don't want that little column that is missing on your analysis that will make everything impossible to do. You want to make sure it's really unique, so there's no duplicates anywhere. You want to make sure that hamburger that you ordered is really the one that you ordered. You want to have consistent service, so every time you repeat the same steps, the same analysis, it always reproduces the same results. You want to make sure it's valid. So if you expect the salt to be within a certain boundary, you don't want to have it over-salted, of course. So this is the same thing for values in your analysis. You want to make sure it's super accurate and timely so that you don't wait 2 hours, you get a coffee and then your analysis is done, or your hamburger is back, right? So this is very, very important. So how do we actually build a 3 Michelin star data warehouse at Picnic? So this is the question, right? So I love this metaphor, so sorry. When your boss tells you, in this case, Daniel over there, okay, so the backend is turning into microservices. So how will the data engineering team look like? How will it scale? How can you guys scale if everything is so fragmented, right? This is the problem. How do we do it? Yeah, you are identifying yourself with this. You probably thought about this. So, because we are really, really 2 different worlds. So, as you know, if you are a backend developer, you know this is true. And please, if I'm saying anything that is a lie, please raise your hand and say Anna, this is not really like this. But you are doing a microservice, you care about exactly your logic to do the job that you were intended to. You care about your storage. You care about your model. Other microservices will have a representation of yourself, but they don't. It's not like you are doing the logic that another service will do. You have totally defragmentation of concerns, and this really clashes with the philosophy of the data warehouse. And this is really the problem, because we have centralized ownership and we want to know the whole model. And every time we need to actually figure out a dependency, we need to end up talking with 10 different services and 10 different products. And this is really hard, and it's actually part of the reason why my job is so exciting. So I'm going to present you what is our secret formula. So how do we actually bring everything together? And this kind of formula is really, is on top of 3 main pillars. So of course, like super cheesy, technology, people, and process, but people are really in the center. So it is very important to understand what are the different roles of people like in your company, right? So we have the data engineers that really care about centralized model. We have the data science and analysts that are really our customers. And you have the backend engineers that you need to constantly work with and communicate. Communication is really key. And when I say communication, this is really about change management. So whenever actually a contract, an API changes, you need to be in the loop at all times. Otherwise, things will not work. And of course, there are tricks to actually make this possible, and I will tell you about it. And so basically, the main things are consumer-driven contracts, so which is something that usually backendies don't like. They don't want to be aware of their consumers. But this is something that we say to our backend developers. You don't need to be aware of your consumers, but you need to be aware of us, because we actually care very much about your data. And we automate things a lot. And because our processes are full of code repetition, we build frameworks to actually automate these things. So how do we work together? So what is the key to success? Hey, Spock. So, as I said, tons of communication. And usually, it starts by, let's say, there's a product. So in this case, let's imagine, for instance, something that is like not boring as a warehouse management system. Sorry, guys. Like, for instance, the store, right? The app. So there's a new feature that is coming. You know, we allow the customers to create their own recipes, for instance. So what is very important is to understand, to get together with the product owner, with the tech lead, and really define what is the contract to communicate, with the stores to actually retrieve that data. And then we ensure that after we define that contract, we really have unit tests and integration tests that will validate the schema that we are waiting for. Either if it is an event or an endpoint, it doesn't matter, but validation is key. And we do a little trick also in Picnic, where we add ourselves as code owners in GitHub. In case you don't know the code owners functionality, check it out. You can actually add yourself as a code owner of a piece of code, and then every time there is a change to that piece of code, you are tagged automatically as a reviewer. This is pretty cool, because whenever the communication and the human part fails, which happens all the time because we're humans and miscommunication happens, at least you have the peace of mind of having some kind of a check that is enforced by technology. So, how does the Picnic data landscape look like? So how does our pipeline look like? And this is the part where I will tell you about our tech stack. How do we actually, what are technologies we use? So, we are a pretty AWS intensive company, and we have pretty much our services running in Docker and on Kubernetes. And we basically have 2 ways of sourcing data. So the first way is like a pushing mechanism, right? So it's through events. So when we have an event, something that happens in the backend application, these events, we use RabbitMQ as a messaging bus. This gets pushed to the queue, and we have this little piece of code that handles the event and basically stamps with the emitter's name. And then we have this really cool framework, Snowplow. If you don't know it, check it out. It's like Google Analytics, but open source and better, because you can really see like the raw. You don't need to pay to actually see the raw events. So if you actually deal with in-app analytics, check it out. We actually use it for everything, even actions in the warehouse. So this Snowplow framework has a collector that basically collects the event from the queue, and then it runs a validation step, where you basically have this repository. It's called Igloo, and basically has a self-describing JSON schema. So it will tell you what are the fields for that event, what are mandatory, what is the data type, and it versions them. So it's pretty cool. So every time the application actually does a breaking change, it can increase the version, and you actually don't lose that data until you consume it, until you have a schema that is the next version, and you actually consume it from the queue. So, and then, if it's good, the event, it goes through EMR that we use to basically load the data into the data warehouse. And we load this into a single table that it's called Atomic, because basically it's a single table for all events in the company, but it's dynamics. So you have more columns depending on the types of fields that the events have. Then the other way is through REST, of course. Our little friends REST. They will never go out of trend. So they're always useful. And we have here Python jobs that are scheduled. So we use Kubernetes jobs and Argo and a ton of stuff. And we basically call APIs, REST APIs, and then we get our data in streaming, like TSV streaming. And then we load this directly in the data warehouse into a modeling technique we call Data Vault. So Data Vault, if you don't know it, check it out because it's really cool. It's a modeling technique that is similar to operational models, so it's really highly normalized, but it's pretty cool because you reduce a lot of duplication in your structures. Check it out. It's really cool because by default it has automatic historization, auditing, and all these kind of things. So it's like event sourcing for the backendies, if you heard about this term. So, and then basically we have these two ways of getting data, but they're very raw, right? They're really highly normalized. They're not yet ready for consumption. If you ask an analyst to actually query this, they wouldn't know how. Because actually here you only clean the basic stuff, but you don't really calculate the KPIs they need. So then on top, you have what we call a dimensional model. And I'm not sure if you know about what is dimensional model. Who of you have heard about dimensional model? Wow, that's pretty good. Basically, this is what we use. So it's like the model that this guy named Kimball invented in the 70s. It's still pretty relevant to make sure. Why are you doing this with your face? Why are you placing Paul? You don't like Kimball? We need to talk afterwards. I'm a fan of Kimball. I'm sorry. So, how do we actually model the business? So now I'll be focusing on the last part, how we actually bring everything together. So imagine, again, if you have an order coming from many different systems, and let me remind you of the previous slide where you had the 24 different services, right? So imagine you have an order that actually comes from different systems, both from the app, from the warehouse system, from the delivery system, and the different applications will have a different perspective on that order, right? So the app will have data regarding the interactions, of the customer in the context of that order. The delivery system will know when did that delivery start and finish. And the warehouse system will know, for instance, who actually picked that order. Some technical problems?
I'll shut down.
We have 44 seconds.
No pressure. Well, it's like the second last slide, so we should be good. Yeah, but then, okay, it's okay, you can just look the other way. It's not going to be weird, you can all look at that side. It's fine. But basically, so you have an order from different perspectives, right? So different data points from that order. How do you combine everything together? Because you don't want to have multiple tables for that order. You want to have one single table, right? So this is how we use Data Vault, so what I talked to you before, and this is actually how it looks like. So you really highly normalize your data. So you have these linking tables that will only have the keys to the tables that will contain the IDs of each entity. So in this case, if the order has the article, so the product and other entities, it will have all the keys, so the order ID and the product ID and so on. And then it has a really cool feature where you have basically tables that historize everything. So every time that order changes the status, for instance, you will have a new record, and you can actually travel back in time and do the analysis as if you were at that time. Then, the dimensional model. It looks like pretty similar, but it's a bit more ready for consumption. So you have less tables, much easier for the business, because the business will use reporting tools that can actually connect to these tables, or they will use SQL directly. So our analysts at Picnic, they all know SQL. So they're pretty well versed in connecting to the central table that will have all the linking keys, and joining with all the dimensions around that will give context to that order. And this is pretty cool because in these tables, you already have pre-calculated things. Like for instance, okay, let's say, for instance, what is the average order value up until this point in time? Things that you would never know from a backend system because they don't have the full history, or if they do, it will be too heavy for them to calculate. So, last slide. How do we actually scale? So this is almost like a sales pitch to Daniel to prove that our team can scale. Daniel is our CTO. So basically, so in Picnic we have about 70 services, microservices, some of them that we read from in data engineering, and we actually have this many tables and this many fields, so more than 1,000 tables and actually 26K fields, and all these fields are really pretty unique. You can think about like, because all the fields are not really the fields that are in the backend. They can be like derived fields, things that you would only be able to calculate if you have exactly, all the fields. And then we have a pretty high usage of our data warehouse where we have about 600K queries every single week. And we have about 200 analysts, so you do the math, and it's about like 3K queries per week per analyst. So it's pretty used. And as I said, because we really deal with all the teams, then we deal with about 30 tech and business teams across multiple countries, and only with 6 data engineers. You need to remember there's only 6 data engineers. And this is only possible with 4 things. So this is the main key takeaways that I want you to take home with you, which is basically contracts, consumer-driven contracts. Make your backend aware that you are dependent on a given data point, on a given structure. Validate them. So work together with the backend to make sure that at build time, the backend knows that you are dependent on that specific field. And then make sure you are part of the coding review process, either by having the code owners or really be involved in the development process. And then finally, tons of modeling. For the ones that don't like modeling, too bad, but you can rely on your data engineers, but you should be able to model the world with these techniques. Thank you. Now, some time for questions. And we have 2 mics, which is a luxury. Yeah, it works.
First question. Very easy for me.
Okay, this is the hard part.
All those 70 microservices that you mentioned there.
They're not all microservices, but a good part of them are. Yeah, it doesn't matter.
Are they stateless, or they are something of a stateless or stateful? So they keep the state?
I have no idea. Because I'm being very honest, because some of them, I know that some are stateful and some are stateless, but I am a consumer.
You have 0 stateful applications on the cluster.
There you go. And I'm pretty sure that's a good thing. So we said that we have 0 stateful services, everything is stateless.
Okay, thank you.
Yes, comment. She was first, I think, then I'll come back. Disaster avoided.
So thank you for your presentation, it's really good. I wonder, how do you cope
within Picnic with documentation about data warehousing. Since many companies I've seen, you come there and they say, yeah, this is our data warehouse. Good luck. That is a pretty good question. So with such a big model, you sure need to document it. So the way we do it, we actually do documentation in code. So, but it's not the way we would expect. So we have comments in the fields we have, and in the views, in the tables we have, and then we actually build these kind of meta dashboards that provide an interface for you to see what are the fields that are available and what are the meaning of those fields. And we actually embed those fields with some Google Sheets that people can contribute to, so that if we don't have documentation for those fields, it looks for the documentation from the person that introduced, as a help. So, does that answer your question?
Yeah.
Cool.
Hi Anna, thanks for the nice presentation. I have a small question. Is it allowed for analysts to query the raw data?
Also very good question, because there's always a trade-off between allowing people to query the raw data and being a bit more fresh, right? Because these processes that I talked about, they're only refreshed once a day because they are pretty heavy. So for certain peoples, we have different roles. We allow them, the analysts that are more well-versed in either in the specific domain or with SQL, we indeed allow them to query the raw data. But we try to minimize this as much as possible, because if we feel that the analyst needs to go to the raw data and actually query it, it means that maybe you're not doing your job very well. Maybe it's a good indication that you should provide something that is more ready for consumption in the latest layer. But we indeed expose raw data exactly to allow them to figure out what they want, and then we produce data sources that actually aggregate the things so that we don't need to expose raw data. Yes?
How do you handle PII information?
What?
How do you handle PII information?
Ooh, also very good question. So, I love this, because we also thought the same. GDPR, we were like, oh my god, what we will do? So actually what we do, this is the part I get very excited. So, so here, when we capture this data here, we store it in different tables. So we actually have specific tables that are just for PII that we store, and then because this layer is not exposed to the analyst, then what we do is we have different roles for which the general analysts will not be able to actually access that PI information. We encrypt it here in this last layer. And then if actually for some reason you need someone that needs PI role, then we don't encrypt it, and we do this dynamically. If actually we need to delete our data because the customer requested to delete, then it's very simple, because we stored the data in a different table here, then all we have to do is delete the record from there, and we don't break integrity.
Hi, could you maybe share us some valuable insights you got from all the data gathering?
Oh.
Like practical.
Okay, practical. This is the part where we focus on the data, not really on the insights, because I'm a data engineer. Can you help me out here, Eliana? I'm now here in depression and I haven't... Drop times. Yes. For instance, the influence that, the fact that if the customer lives in the ground floor or in a flat, it really influences the drop times. Or for instance, if you had an issue in a previous order, usually you take a bit more time delivering that order, at the door of the customer. So there's all these kind of like really cool correlations that are kind of very intuitive, but it's really cool to look at the data and see that is actually the case. Or for instance, something related to CS. Where do we have Sharon? Yes, can you remember anything from CS? CS, like ratings and like really cool correlations. The addresses of people. What about it? Any cool insight from CS? Cool insight.
People like to use emojis.
Yeah. Oh yeah. People that use emojis are usually very happy. And actually, so Sharon is responsible for doing NLP on the ratings that our customers provide to us, and people usually express feelings through emojis. It's amazing. So whenever she finds emojis, she actually can tell if the person is really happy or not. It's really cool because sometimes it's angry emojis, right? So.
Hi Anna, over here.
Yeah.
Great presentation.
Ah.
I've talked with many data engineers, and they always have this frustration in which they feel like almost every pipeline they build, pretty much doing kind of the same, just in slightly different places.
Yeah.
But code reusability is on the floor. Like they're
really? Oh wow.
Yeah. So I'm guessing, like, how do you deal with that here in Picnic?
Oh wow. So
common actions are done the same way in a single.
Yeah, definitely. So this first layer that I was talking to you about is full of code repetition. It's almost like templating. So the way we have automated this is by building frameworks. So we are very lazy. So we are kind of like the smart, lazy kind, and as Dimitri usually says, we basically like to automate things. So we created frameworks for actually generating dynamically this code. So we reduce really a lot of our code duplication. And for instance, if you have like, let's say, two tables that actually use the same kind of way to calculate a given metric, we actually create what we call staging tables that abstract this logic or views, and then we reuse that logic in these tables. So we reduce really a lot code duplication. And I really don't believe if a data engineer will say that they repeat a lot of the code, maybe they're focusing on the wrong area of data engineering. I believe honestly that data engineers shouldn't build data pipelines. They should automate the way data pipelines are written. This is what I strongly believe in.
Want to take another one? Want to take another question?
Yeah, sure, if we have time.
I think maybe this is the last question.
Hi, do you have internal search engine to find queries or metadata?
Internal search engine to find what?
Queries or metadata.
Yes.
By your analysts and scientists.
To find queries, so like useful queries that people do?
Yeah, because like in general, the more queries you have, the more time you spend searching queries, because it's like spread around.
Whoops! I'm not sure I fully understand your question. Can you give me a concrete example?
Yeah, so like for instance, company build data discovery engine or search engine to find queries, because sometimes people get lost. Hey, where's this query for? Do you have queries already? Right?
You mean queries?
Yeah.
Yes. You mean like, for instance, like if there's like a useful query that everyone uses, you might want to have a search discovery engine that you can find like, okay, that is usually the query that I use for this specific analysis, this kind of thing, right? Okay, just to make sure I got the question. So we have it more on the dashboarding side, because all our dashboards are published in a central service, so people tend to, every time they want to do a certain analysis, to always search for what is a dashboard that already does, a bit there. It's like a bit halfway of what they want to do, and they adapt it. But indeed, for queries, we are not there yet. No, I wish. But it ensures that we have a job because they come to us and we sound really smart. Okay.
Will you give me a massive applause for Anna? So, well, thanks everybody for being here, attending these two amazing talks. I think we still have time for some more beer. Looking for some picnic people? Yes. Yes, there is more beer.
And we will be around so you can ask more questions.
So thanks all for coming, and I'll see you the next time. Woo!